Hello guys, have you ever wondered how to move objects in water inside Houdini? They never explain that anywhere, so I am going to show you how to do it in a simple trick. And remember, if you want to learn more from Houdini, you can join into my Discord channel where we have a really nice community where we help each other. Okay guys, so to start with, let's create our geometry for the rib. Let's create a grid. This grid will be 10 by 10. We don't need to have any kind of divisions. And let's create a ball extrude like so. Now, this should be okay, maybe depth of 2.6, and we're fine. So we need to create a river or a concavity here. So there are plenty of ways to do it, and I'm going to choose maybe an easy one. So let's connect this on the left side, and on the right side we're going to create a line, right? This line, if we watch closely, is going to be determined by the following. We're going to rotate this 90 degrees, like so, and let's make this length the same as this width. You see? Now we have a size that matches our box. So we can move it by hand, we don't need to be so precise in this. And let's make it just a tiny bit longer, so we know that we want to list a tiny bit more. So with 4 meters more, it's okay. Now with this we're going to create a poly wire, which will represent our concavity. If we apply these guys together and we subtract, we will see this, right? So let's make this bigger. There we go. Now we can do a convert BDB in both of them. Here we're going to convert this to a BDB, and now let's grab a convert polygons. Now let's do a BDB from polygons. And let's have a poly of 1. We don't want this to be so expensive on our computer. So let's convert this back to polygons, like so. Now, maybe a value 0.5 will be okay, or even 2.5. Now, what we can do is make a point bob. This point bob, we're going to make an easy noise. So let's grab this noise, let's make it 3D, and let's plug the position to the position. Let's make an add, so we're going to add our positions with this noise right here. So as you can see, nothing happens, and we're going to export all these attributes somewhere else. Vex options, create input parameters. Now everything is outside. So as you can see, it works as usual. And now we have our river. We can obviously change this around here with more divisions, and we can do a transform node, or like right here, where we can, for example, on the x-axis scale it up a little bit, like so. This will work flawlessly. Now let's make this a little bit less rough and with less amplitude. And this should work. Let's move this a little bit upwards. This should be okay. Perhaps moving it a little bit closer. You can mess around as you want with this. So this is a river. Let's use Shift O and Shift S, and let's make a collision source. The collision source will consist, first of all, on our volume, which will be having a voxel size, and we will have a node called out poly. This will be the river, and on the other side it will be the BDB. So you want to divide this a little bit more, not in complexity but on clarification or nulls. So let's make a null that says out BDB shape. This will be like the shape that the river will have. This will be the shape our PDB will have after the boolean. And one more, this will be the shape our line will have. So out for it. So now we have our river setup. So now we got to make our initial source right here. So let's make this. Let's also merge our poly BDB because we're going to use it to have a combination. It will combine BDB. So let's also make a box. This box will determine our initial shape. Let's do a BDB from polygons. This will have our voxel size, so will remain constant everywhere. And we will combine all the things. Sorry, we will need this one. Copy and paste it here. Relative reference. Okay, so we have this, and we also have this one around here. What we want to do is the intersection, if I'm not mistaken. So let's extrude this downwards, and let's make our river like so. This will remember this will be the initial water source. So let's make a little bit shallow, and this will be our initial shape. This works just fine. See, A with the intersection, B will give us this. So from this, what we want to do is to make a flip source. The flip source will basically add some points. We can plus them out like so. Now we can see the points, right? So we have a volume, we have surface and some points here. So what do we want to do with this? We have a voxel size and a particle separation. This will be very important later on. And we don't have actually any type of velocity. See? Let's grab our line, and don't forget to add at least 3 points and make a resample node. With this resample node, let's make a tangent, and from this tangent we'll have the velocity. See, now we have the velocity. It was working flawlessly. The velocity is going on the positive z-axis, this one. So it's going over there. Now let's attribute transfer this velocity here, right here. See, now all of our points have velocity, but we need to do one more thing, which is to make point velocity, just to make a little bit more cool noise right here. See, let's make this wall size bigger. We only need a tiny variation, not that much. This is okay. Let's move out the initial shape. So let's Shift O and organize this a little bit. Let's make our dot network. Now we want to grab this and these two guys. How do we do this? The following. Let's make a flip object somewhere over here. Let's already grab this particle separation and plug it in here in the flip source. Particle separation here, base relative. Now these two guys are linked, so let's do a 0.8 perhaps. And we do not want this one. We want a flip solver, like so. And let's grab our initial shape. We should have something like this. Look, nothing at all, because we need a particle field to show these guys. This might be too much, so let's do a 0.4. And the visualization will have to be, instead of sprites, particles. This is really not too much, so let's go further and further until we are happy with it. This should work just fine. So what we want to do is, in this case, to have like our bounding box, this one on the volume motion, the limits, kind of similar to where we need to have our particles. So let's add space 2. Let's shrink this here. Let's also shrink this one here. Remember, we're going on the z-axis, so maybe we need to have these two guys together, like so. So basically what I did is to displace this box where the water is going to go, so around here. So we press play, nothing happens, but we only have an initial velocity, which we added before. So let's add some gravity, and let's add a merge, right? So here, and the static objects. This static object should go on the left, and we should plug in the software our poly river, and on our collision we are not going to display this, and on our collision we should use volume collisions. This should be set to volume sample, and our proxy volume should be set to poly BDB. Let's visualize this, and we have our collision. So now that we are watching this, we can adjust this a tiny bit more. This is going to be our maximum border, nothing else. So let's press play. See, this is moving correctly. It will continue for 10 meters and then go to the bottom. This is our initial shape from the river. So we can reduce this a tiny bit more to 0.5. So in order to visualize what's actually being active, we should go to Flip Object, in Guides, Visualization, and plug in the collision. You will see this will expand as the particles go forwards. So this is a really optimized scene. So let's improve this a little bit. We need to plug this into swirl kernel. We need some vorticity. We need some rest. This set to 25. Remember, we are not going to cover shading, but you will probably need this in every situation. Let's add a little bit of particle separation. 1.2 will do. And this should be it. Let's see how this looks or behaves now. This is a little bit thicker, and overall I'm really liking how this looks, as for being a low res simulation. So let's move forwards. So we want constant flow here, right? What we need to do is to make our boundary layers. This option, use boundary layer. We do not have a boundary layer here, but we already know that on at least the x-axis we have a space for a boundary layer, so we should be very precise on this and move this just on the edge, like so. And we can have a padding. This will be the lower z-axis, x, y, and z. This should be set to 0.5. 0.5. So what have I done? Now we should be having on this lower side a place where particles will start advecting over and over and over and over. See how this is working? And do you see how this is kind of creating new particles? But well, we need to have some kind of actual volume for this to work properly. So let's go here. Let's grab our box, which we're going to make a mold. So this is more tiny. Let's create this. We will say this to out box. So let's object merge this one here. So we need to make a bundle layer. So let's make a mold because we're going to need the following. You see this? We're going to make a bound box out of it. This will be the out big box. So let's object merge this one here. Okay, so what we want to do now is the boundary layer. So let's make a new layer. This is where we're going to take our B-box and let's do an merge here with this shape around here. So we have our boundary box, right? So what we want to do now is to make a bound layer. In this case, we're going to just copy here and paste this here on the lower padding. Now we want this to be a negative number. And from this we want to have our boolean. our boolean will basically subtract both of the things together. See, now we have this. So let's turn this into a BDD from polygons, like so, and let's option merge this guy, the out river shape. The out river shape will allow us to basically carve one from another with a BDD combined. This should work just fine with an intersection. Now we have our boundary layer. This will obviously have the following, like so. In fact, we're going to copy everything here. Ctrl-C, Ctrl-B, and let's only change this guy here. Now, we have the following, that we need to divide this into the surface and the points. So this is our out layer surface, and we should have a split. The split will divide our surface here with our velocities. This should have to be rasterized volume, rasterized attributes. They got to be like so, rasterized. If you watch closely, we will have these velocities moving from time to time. This should work. Shift O. If we go inside here, let's go into the first frame, and let's plug into the surface volume our layer surface, and I forgot to change the name of this to out layer B, so we can differentiate. So our velocity volume is our out layer B. So let's see what happens. So as you can see, we're not reaching the volume because of our surface volume here, the padding. So we don't have to be so accurate. We can move this a little bit and it will work just fine. Maybe a tiny bit more, and there we are. See, now it's a constant flow of velocities and points. So perhaps in order to see this better, we might need to have a little bit more resolution, and let's see what happens. Something that might be happening here is that we don't have enough volume right here. See, this is a very tiny portion, so you can adjust this a tiny bit and do a multiplication by 2. This will now fix our problems, and we should have a ton more particles going into the simulation. Okay, so this is nice. These variations in the shape are due to the velocities. So now that we got this, we want to do the RBD part. But first of all, let's do a dop import fields. Let's grab this here. Let's only use our flip object. Let's choose flip fluid. We will have everything here. Let's compress, fluid compress. So we have these kind of cubes. We can access this later with a fluid surface, either meshed or as I like to have our compressed fluid surface particles. You can visualize this with velocity, with vorticity, as you please. So let's make a file capture node. This will be called file res b01. You should save this as I said here with $hip cache $ros bgob.cs. Basically, this will be our location for the file, and we will have here our out particles flow. Let's add a rasterized attributes. You will see why here we will need our velocities fields. But first of all, we need to cache this out. So let's cache it out. Let's don't forget to add a $F4 and cache this out. Okay, so now that we have this, as you can see, we have some velocities over our particles. We can visualize these particles around here, and they all work flawlessly. Look at this, it's beautiful, and this is only a low resolution. So, what we want to do is to make a null, which is out B, S, Shift O, all of them, and let's create our RBD. So let's go to out, do an object merge on out poly river. We will need to extract this db inside a primitive group, and we will scatter some points. You guess where? On the b inside a. Let's not relax, and let's only have like 30 of them. So let's copy 2 points, and let's use these points to make a box, and we should have a normal set first 2 points here. So let's see how this looks. This looks awful. We should have something like that, and like so. And we do not want to have this one, so I messed up on the edges. So let's look for our, there we go. We need the z-axis, and this should be set to 0, and this should be set to the half of this. So let's copy and let's divide it by 2. Now everything is standing on top of the surface. So let's make this a tiny bit more tiny, a tiny bit more tiny, and we can make this smaller. In fact, we don't need to have that much. This is only a demonstration. So this will be our null outer bit. So in order to affect this by the water, we need to have a dop network. This dop network is going to be referring to our RBD, but you can plug in whatever you want. I will suggest you to follow this. Let's make an object merge. Let's drag this in here. We know that we want to have, in this case, an assemble node, because this is an RBD, and the RBDs are with packed primitives most likely. So let's plug this in. Let's toggle these 3 guys, and this will be our maybe wood planks, right? So we can create the name, and we'll have all the planks together. We have all the names, right? So this will be null out loud, right? If we want to be even clearer, perhaps here, I'm not going to do anything, but here you can do high poly version, as in my other tutorials, and in this case this would become our out high, like so. Remember to use an RBD pack to have our high and our low together. You could use constraints, it depends on what you want to break, and an RBD on pack. And remember, we usually end up just plugging this straight over here and doing the following, since we're going to be referring this right on the bottom here. So we should have something like this. This is basically a process. Let's grab all of them together and let's hop into our dop network. What are we going to need? For start, we are going to need an RBD packed object. The RBD packed object will basically consist on our low, out low. Let's go into the first frame. We'll have this one. Let's add the gravity node, and let's add an rigid body solver. In this case, we're going to make also a merge node where we're going to have a static object plug into here on the left side, and we're only going to grab our poly river. So as you can see, this falls and it works. Maybe there are some intersections here, but we could fix this, for example, by going to the collision using the surface solver and on bullet data using a concave. So if we display the geometry but keep our guided geometry, you will see it's the same. So let's see how it works now. Some of them fall, so perhaps what we actually want to do is to offset these scatter points just a tiny bit. So how do we do this? With a pick node after our normal. So let's only use on the B inside A group, and let's drag this a little bit here so they're not intersecting with the original geometry. Let's hop in again to our dop network and let's see what happens. They all stay on top. Some of them fall, it's okay. So I'm just going to make a small change because I want them to be thinner. This will be alright. Now we have tiny little planks. Let's see what happens. This is okay. But we want this to move with the water. So far it's not working. So let's use advect by volumes, advect by volume, yeah, and use in the post solve grabbing our out B, and instead of velocity use B. We will update the force and we will see what happens. This is taking a little bit long because I should have used a low resolution geometry here. So before fixing this, we're going to make a new take. This take will be called, if we go to Windows and take list, it will be called proxy. Inside the proxy here, we are going to allow new takes. We're going to hop in and move this to 0.5. This will make everything faster. See, it's very fast, and we're going to reset this here. So now that we have this, we can see this is way faster to playback, and we should go inside here, and this should work just fine. See, look how faster this is, and we are seeing some kind of movement, not much, because perhaps we need this to make a little bit slippery. So let's go into physical. The friction will be set to 0.4, bounce will be set, this is okay. So let's look at this again, and we should be seeing some kind of react. See, we're watching some kind of drag. This is due to the water, but I want to have more. So let's velocity scale set to 2, and let's look closely again. Now we're watching way more movement here, and this should be ready to go. So now what we actually need to do is to make a transform pieces. We're going to grab the high resolution, and we're going to be advecting it by the low resolution, just in case, so you can see what happens. We could divide this, right, with a divider, and you can use a brick. This size will be smaller and smaller, and we could use a mountain like so, and we could assemble this up like so. And when we use the following, all the pieces will be advected. This will work, right? So in fact, let's use this as a test. Let's go inside here, let's plug this in here, and let's make the mountain a tiny bit more interesting. setting the element scale lower, but also the height a little bit lower. This will work just fine. So once we have this, we can see this works really nice, and we're going to copy and paste the following. This Shift O, we're going to drag all of them this, see, and here Shift B. Let's move this aside and let's turn back that there, and let's do a final thing, which is connecting these two guys together. This will be the planks, and this will also be the planks. Shift O. This is our RBD. This is our proxy simulation, and we're almost ready to go. We are going to copy this again. We're going to paste it here, and we're going to hop in. Inside here, we basically only need to add one more static object. The static object will be set to copy this one here. This will be the out polyplanks, and out polyplanks here, and this will be the out polyplanks 1, which is in this case debri. There we go. So if we go inside here and we press play on proxy, just so we can see, we will have something colliding, see? But it is not moving. Why? Because we need to set this to deforming, in deforming geometry. Now this should work just fine. See? They are moving with the water, and they are causing some collisions on our simulation. And it kind of does the trick, right? So let's increase our resolution. Let's go back into main. On particle separation, remember the whole setup is controlled by this dop network. So let's do the following: 1, 2, 5. We are going to have a really nice amount of resolution here. This is 0.2. We're going to have 130,000 points, perhaps 175. This should do the trick. Yes, 200,000 points. Let's save this before, and let's merge these guys together. This will be the out I 1, out B1. We're not needing these guys. Our particles high. So let's merge this guy here. Let's also follow this one. Let's connect our polyplanks, and let's connect our river right here. So we have everything that we need. So let's watch how it looks. Let's make a flipbook. And this is how it looks after only 10 minutes of catching, or maybe a little bit less. It looks really good. I mean, we could pump a lot more resolution. And as you can see, we are having the illusion this simulation is dragging our pieces, when in fact it is a low-res simulation. So this is a really nice trick when you want to pull things out faster. Okay, so one thing that I did is to create this particle surface, and I just copied into a new simulation this particle separation. Then I went back and pasted the relative reference like so, and I reduced the droplet scale from 1 to 0.5, and as you can see, the overall result is very interesting. This is how it looks without the mesh, and this is how it looks with the mesh. Of course, it needs a white water simulation on top of it, but so far this is a really good starting mesh. Hi guys, I hope that you enjoyed the tutorial. Please leave a like, comment, and if you have any type of problem with the setup, please tell me and I will try to solve it. So until next time. Oh, and I forgot, don't forget to join my Discord channel if you want to learn more about Houdini. See ya.